So this is Crabby Patty coming from Matt's basement. You want to learn about fidget spinners? You come to me because you probably don't know anything about this because you don't use them like I do. The other thing is there's physics to do with this. You might not have realized it, but there is. Well, let me backtrack a little bit because you need to know about the history of them first. So these things were created in 1993 from some girl that I have no clue where she is from and whatever, but she created them but never patented them. Don't know why. She could be making bank right now, but her loss, my gain. To make them, they're mostly 3D printed. Like the bases are 3D printed, but like then they include bearings and then the plastic tops and then like bearings on the outside so that they keep spinning. But then also the center mass is in the middle, so like it keeps spinning faster and the ball bearings also create the less friction in them, which causes them to spin longer. Like, except this one sucks, so that's its problem. But this one works so much better because it spins faster and it's tinier and less mass makes it go faster. But each has the ball bearings, which, if you can see, this has ball bearings right in the middle and doesn't have a top because I broke it, but that's not my fault. But no, also, like, if you think about it, Newton's first law is in play because if an object in motion stays in motion, it can do that, whatever. But if it's acted on by outside force, it will stop, which basically is what I'm doing right now. So this thing will keep spinning until I'm done, but I want to stop it now so that we can go talk to Matt about some math to do with physics and fidget spinners.
Alright, might be a little loud with the fidget spinners going, but that's alright. Alright, here we go. The math behind this pretty easy, alright? So, on average, we got the degrees of one of the tripod areas, right, is 160 degrees, right? Which is approximately 2.79 radians. Alright, and then time for that is an average of 0.53 seconds. So you bring that over, find some velocity, right? Which you can do by angle over t. Right? So then velocity is equal to 2.79 over 0.53 seconds, which is approximately 5.264. Now these are constantly decelerating, right? So this is a negative velocity, right? And it's also radians per second. Gotta have the labels right. Alright, bring that on down here. Velocity, right, is negative 5.264 radians per second. And you got your radius is 0.0381, which then bring that on over, right? Same equation from up here. Basically, velocity over radius will get you delta butt, which is what you want here. We got negative 5.264 over 0.0381, which is approximately negative 140 when you round it, radians per second. So this is your delta butt. Alright, so then you bring that on down here. Again, we got delta butt is 140, negative 140 radians per second. And the average time one of these fidget spinners goes for is about 104 seconds, right? So then, to find the angular acceleration of these bad boys, you take A, right, equals delta butt over delta t, which becomes, when you plug it all in, A is equal to negative 140 over 104, which is approximately negative 1.346 radians per second squared. Alright, that's your big angular acceleration. You have 1.346 radians second squared.